Hello, scholars. As you already know, I like to keep you company. Tonight, our topic of discussion will be annuities. We'll be looking at their future values and their present values. In my previous lecture, I have explained what future values and present values are, how to calculate them. Now, we did it for other kind of investments, but this time we are focused on annuities, which is a very, very important type of investment. Now, what is an annuity? Well, a simple way to explain it is that it is a series of payments or receipts. So it can be payment or receipts of a fixed amount for a specified period, such as payment for your car loans. So for the company that receive your car loan, it is an annuity for them, and it is a receipt, So mortgages, insurance premium, student loan, all these things are annuities. Even 401k payments, retirement payments, these are all annuities. They are fixed, they are periodic, and it lasts for a specified period of time. So, in other words, an annuity is a series of payments or receipts of a fixed amount for a specified period of time. So, we have two types generally. We have the one that we call the ordinary annuity, or another name for it is deferred annuity. So, this is the kind of annuity with a fixed number of equal payments occurring at the end of each period. Good example include car loan. So you pay it at the end of the month, or at the end of if it's a monthly payment, at the end of that month, at a particular date, you send your payments. Mortgages, student loans, and so on. Then we have annuity due. If payments are made at the beginning of each period, then we call it annuity due. This type of annuity is a good example is rental lease payments. Another good example is life insurance premium, when you pay in to the system, and then when the person, maybe your spouse or whoever it is insured that dies, now you receive a lump payment from the insurance company. But you pay at the beginning. You keep paying, make the payments. You pay payments, you use it, if it's a car note. An auto insurance. For life insurance, you keep making payments every month until when it is the person that you are paying it for, it became deceased, and then you receive the lump payment. Another one is lottery payoffs. People win lottery, and they might request for periodic payments, maybe a kind of annuity whereby you will pay a specific sum of money until the annuity expires. Okay? Or maybe the money expires or finishes. Now, in Excel calculation, we use 0 to represent the ordinary annuity, and 1 for annuity due. Now, let us explain more about this annuity, because it is a very important type of investment. Why did I say that? A lot of people invest in annuities. Some people don't understand stock and bonds, so they put their money in annuity. Okay? Now, look at this. That's immediate versus deferred annuity. Now, these are the kind of options you have annuity. The option can be an immediate annuity or income annuity. In this, or it can be deferred annuity, just similar to what we just explained a few minutes ago. So for an immediate or income annuity, payouts, you can begin receiving payment within a year. So people who expect to retire very soon may use it as a way of getting a supplementary income. So an example, again, is the lottery. Like I explained a few minutes ago, when people win lottery, they usually receive their winnings in form of lump sum payment. However, there are some people who might choose to receive their winning as an annuity. That means they will pay you, say, let's say 100,000 every year until the money finishes. So in that case, they will get regular payments over the time instead of a lump sum. Another good example is when if somebody pays a single premium, say 200,000 to an insurance company, and then receive monthly payments of about, say, $5,000 for a fixed period of time. So that can be an annuity. The payment might be made every month or every year, depending on the type of annuity that you have. There's a way to calculate the payments amount that they will be paying you each month. So first of all, if we invest a lump sum, depending on the agreement you sign, the contract you sign with the company, it's okay. You invested $200,000. Then for the next 5 years, you'll be receiving $5,000 every month for that 3 years. So which is a good investment and be a good investment, depending on the percent of their returns or the interest in their annuity. Now, most insurance companies have this kind of annuity. A good example, like a Nationwide Insurance, have this type of annuity where you invest the lump sum, and then over the given period of time, you receive fixed amount of payment until the number of years you've signed on the contract expires. Next one is the deferred annuity. This one does not pay any annuity for many years after they are purchased. So usually the payment is deferred until retirement. A good example of this kind of annuity to have a pension fund is a good example, or retirement fund. I call it retirement fund. Fund like 401k plans, 403 plans, which are all pension plans, are a good example of deferred annuity. So you buy the annuity. When you are working, you'll be paying periodically into the annuity. So after 20 years you decide to retire. When you retire, then they will start paying you a fixed amount of money every month. Some people might say, I like to receive $1,500 every month for the next 20 years or for the next 15 years, depends on that. Now, I think I have given you enough background about annuities. Now, let us take a look on how to calculate their future values and their present values. Now, when it comes to calculating the future values and present values of annuities, there are 4 methods that we use, or we can use. I will call it 4 options. You can use the formula method, or you can use the tabular method, using table, or the spreadsheet method. Now, for those of you who have finance calculator, you can use that if you have. That's the 4th method. Okay. Now, let's start with the use one question, and we're going to use the different methods to solve that question. Okay. We'll be using we use 3 methods to solve this question. The question says, make sure you're seeing this. Okay. Question says, assume that you are planning to invest $7,000 each year for 6 years, and you will receive 8% per year. Determine the future value of this annuity if your first $7,000 is invested at the end of the first year. So for this, we have we're going to use the formula method, the tabular method, and the spreadsheet method to solve this question. So given that you make your first payment until the end of the first year, this is the kind of ordinary annuity, because you make the payment at the end of the period. So the formula we'll be using is the formula here, future value of the annuity, PMT, which means payment times 1 plus r to the power n minus 1 in brackets divided by r. The r is the compound interest rate, and n is the number of periods. So for this, the payment is 7,000. So let me write this down. Payment is $7,000. Okay. Rate of return is 8%, which is 0.08. You can see it here on the screen. And is number of periods is 6 years. So we can plug it into this formula. Future value, interest, future value of the annuity comes payment, okay, times 1 plus r to the power n minus 1 in brackets divided by r. So let's go and put it. I'll put this in the calculator. Let me write this formula down first of all, and then we can go and put it in. Okay, 1 plus r to the power n. Okay, we put it in. Future value of annuity equals payment, okay, times 1 plus r to the power n minus 1, okay, divided by r. Okay. So we go and put it in the calculator, and then to get our results. And you can see I did the same work, here as well to show you the steps. Now let me take you to the calculator. I think it's gonna be here. Say the payment is $7,000 times, okay, 1 plus r is 8%, which is 0.08. Okay, raised to the power n. N is 6 years, so 6. Okay. Okay, minus 1. Okay, minus 1. Okay, so from here to here, you're gonna enclose it in the parentheses. Okay, include this. Then, so this part, the whole of this part, then divided by r. Remember, divided by r, because the if you look at the formula, it says divide everything by r after you put this part in. So we got, so divide by r. So divided by r. I'm gonna close it and divide by r, which is point. I think I made a mistake. I'm gonna put the division here. Okay, let me put the division here. So the whole of this part and this part. So divided by r, which is 0.08. So you can see that 7,000 times 1 plus r to the power 6 minus 1 divided by r give me $51,351.50. So I can see it from our PowerPoint presentation. Let's see right here. So you can see 51,000. Okay. That's 51,351.50. Okay. So that's using the formula method to get this. Now, so the present value of that 7,000 is 51,005. Sorry, the future value is 51,535, $51,351.50. Now, if it's 7 times 6 is 42,000. 7 times 6 is 42,000. So, so the gain from this will be 51,351.50 minus 42,000. So you can see how much it makes. from this annual investment. Okay. Another way you can find this future value is to use the spreadsheet method. Actually, I want to use both of them. Let's look at spreadsheet method. Okay. Then we'll look at the tabular method. For the spreadsheet method, remember that the payment is 7,000. PMT equals 7,000. Now, because the money is going out of your pocket every year, so you make it negative, so to show the direction of the cash flow. Rate is 8%, and its number of years, 60 years. Present value, you have no present value, is 0. Then type is, because this is an ordinary annuity, type is 0. Remember, I mentioned that at the beginning when I said that for ordinary annuity, input 0 for type, but for annuity due, use 1. Okay. So type is 1. So we go to I'll take you to Excel where we can put those numbers in and do our calculation. So we have it here. The interest is 8%, 0.08. Number of years is 6 years. Payment, the money leaving in your pocket is 7,000, negative 7,000, to show you the direction of the cash flow. Present value, there's no present value. Future value type is 0. Now we can compute the future value of the annuity. This is the formula we use in Excel for that here. Okay. So put equal sign FV, which is future value. Okay. For opening parentheses, you can see them right here. Rate. Let me make sure you're seeing this first of all. I think you're seeing, yeah, good, you're seeing it. Rate is 8%, comma. Number of period is 6 years, comma. Payment is the 7,000, comma. Present value is this, and future value is this one. Close the parentheses and then press the enter key. See, the same thing we have, $51,351.50, which you can see from our formula. The answer we got using the formula method. You can see right here, $51,351.50. So the same results. Okay. So when you use the spreadsheet method, get this. Now, when you use the tabular method, now the formula will become FVA, that is the future value of the annuity, equals the payment times future value interest factor for annuity. So this part here represents or show how a $1 annuity grows or increases with various interest rates and time periods. So for this side, you're gonna choose the intersection between 8% and 6-year period to get this part. Then multiply the 2 to get your answer. So we're gonna use this table here. So let me open the table so you can see it. Okay. So the future value, this one is for $1 compounded amount, but we're using annuity. So you get table A2 shows you the future value. Let me make sure you can see it. Yeah. Okay. So table A2 shows you the future value interest factor for $1 annuity compounded. So let us solve this problem using the table method. Now, taking you back to the question. Remember, the question was assume that you are planning to invest $7,000. Okay, amount is 7,000. Payments, how much you will pay in the insurance company or whatever company that have the annuity. $7,000. Number of period is 6 years, and rate is 8%. So that's now that is the information you need. before you go to the table. Don't forget that the formula is this future value of the annuities, payment times future value interest factor. So taking you to the I'll take you to where I put this in Excel so they can make it clearer for us. The payment is 7,000. Okay. Now, future value interest factor you can find from the table under 8% and 6 years. Let me show you this. You go to the table, but make sure that you are looking at the future value interest factor for annuity. So 8% is right here for 6 years. See, 6 years. See, this one is period. So for 6 years, you follow it to under 8%. And see, right? See the value here. And make it, maybe I should make it a little bit bigger. Okay. See the 8%, 6 years, go all the way here. See 8% and 6 years. So you can see the intersection. So future value interest factor for annuity is 7.3359. So you can see right here. So I'm taking it to 7.3359. Let's see 7.3359. So that the future value of this annuity becomes just formula says payment times the future value interest factor. So that means to multiply these two equals this times that. See, the same thing we have. Okay. I said that here. This one is 50 cents, this one is 30 cents, which is negligible. It's probably caused by the random error, you know. So you have seen the three methods. I've shown you the formula method, I've shown you the spreadsheet method, and I've shown you the tabular method. I'm sure you're enjoying this. I'm also sure you're getting good at this. Now, I like to do examples because the more examples you do, the more you get better at things like this. Look at this example says, assuming that you plan, excuse me, you see. Assuming that you plan to buy a condo 5 years from now, and you estimate that you can save $2,500 per year towards a down payment. You plan to deposit the money in a bank that pays 4% interest. And you will make this deposit by the end of the year. How much will you have after 5 years? Now, this is a future value for ordinary annuity because you make the payment at the end of the year. So the type will be 0. So let's see. Let me write down your information. Yeah, the interest the bank pays is 4%. Okay. Number of periods. You say that you plan to deposit money at the bank and you make the you are buying the condo in 5 years' time. So number of periods is 5 years. The payment you're making is 2,500, which means money leaving your pocket. So negative 2,500. Why did I say that? Because you'll be using Excel. Excel, you have to show the direction of the cash flow. If it's money coming to you, just then you write positive 5,000. But since the money is leaving your pocket, you put that. Now, present value, it doesn't have a present value. Type is 0. So because it doesn't have a present value, we use 0 for that. Now we can, this is the formula here. I'll take you to Excel so we can impute these values and then get our calculations done. Okay. Let's see, interest is 0. 1 minute. 1 minute. Make sure I have everything right. Good. Okay. So interest is 0.4%. Number of periods is 5 years. Payment is negative 2,500. That's 2,500. There's no present value, so you put 0 there. This is an ordinary annuity, so the type is 0. So that means then the formula again is equals future value FV. Once you put the parentheses, the formula will just show underneath it. You can see the rate, which is 4%, comma, number of periods is 5 years, payments, $2,500, present value, which it doesn't have, so 0, comma, future value. Type, end of period, so that is 0, since it's an ordinary annuity. So you get $13,540.81. It's the future value of the annuity. And you can also see this answer in my presentation here. Okay. So you can see that this is really easy to calculate. Having explained this, it is good to proceed to the next step, which is the calculation of the present value of annuity. Generally speaking, many present value problems involve cash flow annuities, and usually they are ordinary annuities. I can show you the tabular method and the spreadsheet method as well. Let's look at example 3. It says, determine the present value now of an annuity of an investment of $5,800 made 1 year from now, and an additional $5,800 made 2 years from now. So I'm sure you're depositing $5,800 for a period of 3 years, 1 year and 2 years from now. So 1 year from now, and then an additional $5,800 made 2 years from now. So okay, actually 2 payments twice. Yeah. So for 2 years, you made this investment. Okay. So the formula, if you're using the table, is payment times the present value interest factor for the annuity. So this part you get from the table. You get it at the intersection of 5% and 2 years. Because you say that the present value is for an investment of $5,800 made 1 year from now, and an additional $5,800 made 2 years from now. So 2 years investment, if the annual interest rate is 5%. So from table, the present value interest factor, the payments, let me write them down. Payment is PMT is 5,800. Now from the table, we get present value interest factor for 2 years under 5%. So present value interest factor for 2 years under 5%. Now let's go and I'll take you there. Table. Now let us look for present value of annuity. This one is not for annuity. Remember, you have to be the one that is for annuity, like this one. Present value of interest factor for $1 annuity. Okay, for 2 years under 5%. Just making sure that you see this. Okay, for 2 years, you go under 5%. 1.8594. 1.8594. So let's go and put them inside the table in Excel to make it easy. You can use calculator if you want. But I use Excel because so I can show you compare the results. Okay. 5,800. And the present value interest factor for annuity is 1.8594. Okay. So the formula is this: multiply the 2 payment times present value interest factor for annuity equals this here 5,800 times, in Excel you use activity present times this. That gives you the result: $10,784. So this is money, so I'm gonna make it currency. So $10,784.52. when you look at what you have here, you can see right here, the same thing we have here. Okay. So this is the table method for solving this. Let's look at the Excel method, but let's write the information down. The interest is 5%. Payment number of period is 2 years. Payment PMT is 5,800. So you got a negative since it's money going out in your pockets. So we have it here. You can see this there. There has no future value. So you put 0 there and have type. Since the end of the period is met, payment is made is 0. So you can go and put this in Excel to get our present value. So you have it here. Interest is 0.05. Okay. Number of periods is 2 years. Payment is negative 5,800. Future value, there's no future value. So here, type 0, since it is I would say ordinary annuity. So equals present value PV. Remember the formula is right here. PV, interest, number of period payments, future value type. Present value is PV, opening parenthesis. You can see the rate here. Click on it, comma, number of periods, comma, payment, comma, future value, comma, and type. You can see the 0, end of the period. Type is 0. Close it, and that'll give you the answer. You can see the same thing we have here. $10,784.52 versus this amount, $10,784.58. So just a difference of 6 cents. Negligible. Usually this difference is caused by the rounding error. Okay, and you can see the same result here on our PowerPoint presentation. So now let's look at question 4. It says, what is the present value of a loan that calls for a payment of $800 per year for 8 years if the discount rate is 7.3% and the first payment will be made 1 year from now, and it's at the end of the period? How will the answer change if the $800 per year occurred for 10 years? Okay, now, so you're going to calculate it for a specific time periods. Again, the interest is here is 7.3%, which is 0.073. Number of period is, it says, a call for the payment of $800 for 8 years. So 8 is the number of periods. We have the payment. PMT is 800. You'll be making $800 per year. That means money leaving your pocket. So negative 800. And we have the next one is future value. It doesn't have a future value. So it puts 0 there. Type is 0. 0. So now let's look at the first question. So we go and put it in. Okay. Now we have interest is 0.073 for 8 years, and payment is made negative $800. Since money is leaving their pocket, no future value. Type is 0. Okay. So present value interest, the present value of this investment is equals PV, opening parenthesis, rate is 7%, comma, number of years is 8 years, comma, payment is this, comma, future value, type is 0. Close it. $4,777. Okay, $4,777. Okay, which is what we have here. Okay, $4,722. Now, note that I want to show you something. This is ordinary annuity. Okay. Now, suppose that the payment is made at the beginning of the period. That means deferred. That is annuity due. I call it annuity due. Due. In that case, you copy the whole thing and then change type to 1. That's the only thing that you change. Okay. So I want you to watch this number here when I change it to 1. So type is 1. Type is 1. So you can see, watch out. See? So even you see, because it's paid at the beginning of the period, not at the end. See the difference in the result. Now, but we're not interested in annuity due here. Why? Because the question didn't ask us for that. The question asked us to find the payment after 8 years. What the future value will be after 8 years. Sorry, what the present value will be after 8 years. The other question they asked us is how the answer will change if the payment was occur for 10 years. In that case, you will have it here. So this one is for 8 years. 8 years. Okay. This one is for 10 years. Years payment. So let us return it to regular annuity and ordinary annuity. So the thing that we need to change is the years. Change this to 10. And you will see, watch this when I click calculate it. You can see the difference. So the longer the period of payment, the more longer the period, the higher the present value of the annuity. I'm very sure you're getting good at this. Okay. You can also see it here. Let's look at this one. Okay. It says here, assume that a bank loan requires an interest payment of $64 per year and a principal payment of $1,000 at the end of the loan's 8-year life. At what amount could this loan be sold for another bank if the loans of similar quality is 6.4% or carried a 6.4% interest rate? That is, he's asking you what is the present value of this loan. B said, now if the interest rates on other similar quality loans are 10%, what would be the present value? Then C said, what would be the present value of the loan if the interest rate is 5% on a similar loan? Okay, let us get ready for this. First of all, let's write the values. The interest for part A is 6.4% right here. So I mean 0.064. Okay. Next, the number of periods for part A is the 8 years, I believe. It says 8-year life. So 8 years. So payment, it says $64 per year. So you're paying $64 negative 64. So the future value and there's a principal payment of $1,000. So that means another payment. So future value is $1,000. So that means bank loan, they give you the loan. There's a principal payment of $10,000, then $54 per year for that 8 years. Okay. The next one is in. We know what else we did is the time. So the time is at the end per year, as well at the end of the year. So it's ordinary annuity 0. So let us go and put these things in and get. So you say, at what amount could this loan be sold to another bank if loans of similar quality carry 6.4% interest rate? That is basically asking you for the present value. Having all these things in, let's go and put them in our Excel and calculate this. So have it here. Interest is 0.064. Number of period is 8 years. Payment is $64, which is 64. Okay. Future value, principal payments, of course, negative $1,000. That's because you got to show the direction of the class. You have to show the direction of the cash flow. Type is 0. So that's equals future value. And present value. Remember, this is present value calculations. So you're going to be present value equals PV, opening parenthesis, rate, comma, number of periods is 8 years, comma, payment is $4 to value, and of course type 0, because it's an ordinary annuity. Then press the enter key. That gives you what I may see. I think I missed something here. Okay. Yeah, I missed something. Yeah, I didn't miss anything. $1,000 will be the present value. I didn't miss anything. It's $1,000. Yep, $1,000. Okay. So now, the other question they ask us is to find, that's part B. Now, if the interest rate on other similar loans are 10%, what would be a present value? So let us go to spreadsheet. Now, I just want to make sure you see this. Okay. Now, in that case, 10% interest. Okay, interest. Okay. Now, one good thing about Excel is that when you do one calculation, you can copy the formula and use it for different computations. Okay. Now, this one is for 10% interest. Let's do this together. Part C, it says, what would be the present value if the interest rate is 5%? So we can go and put, second one is for 5% interest then. This one before 5% interest, 5% interest. So all we have to do is to change the interest rate. I want you to look here at this answer when I'm changing it. It's for 10% interest. That means 0.10 is for 10%. Watch me. Watch here. As I click it, it's become $807.94. And when the interest is 5%, just change it to 0.05. And watch this when I change it. When I click outside, see $1,090.48. So the interest decreases, the present value increases. Interest increases, the present value decreases. The rate of interest. And you can see all this in our presentation here and here and here. Okay. Now, there are key points on Annuity Due. I believe I have explained this before. Because each payment occurs one period earlier. Because for Annuity Due, the one we did so far is annuity, ordinary annuity, where you make a payment at the end of the year or generally at the end of the period. But for Annuity Due, you make a payment at the beginning. For example, for car insurance, you make a payment, then you use it up, making another payment. So we call them Annuity Due. So because each payment occurs one period earlier with Annuity Due, then the payment will all we all earn interest for one additional period. So therefore, future value for annuity due will be greater than a similar ordinary annuity. Let's try this example. Assume that you plan to buy a condo 5 years from now, and you need to save the down payment. You plan to save 2,500 per year, with the first payment being made immediately and deposited in a bank that pays 4%. How much will you have after 5 years? Again, first thing we do is to write down our values. The interest is 4%, right? 0.04. Number of period is 5 years. Okay, payments, PMT, is 2,500, which is negative 2,500, since we must show the direction of the cash flow. Future value, present value, there's none, put 0. Then for time, because you make the payment immediately at the beginning of the year, type will be 1. So let's go and put this in Excel and then do our computation. Okay. So you have it here. Interest is 4%, 0 points. Okay. Number of period is 5 years. Just to make sure you are seeing this. Oh, good. Payments negative 2,500. Present value. Excuse me. Let me. What happened here? Yep. Then present value is, there's no present value. Future value type is 1. So, okay, listen, keep doing this. So let's look at this. Future value becomes equals FV, opening parentheses, for the rates, comma, 5 years for number of period, comma, payment, comma, no present value, comma, that's 0. Then 0 because this is annuity due, so you're gonna use 1 for type the 1. Okay, let me undo this. I should again, future value, FV, opening parentheses, interest, comma, number of period is 5 years, comma, payment is 2,500, comma, present value, there's no present value, so it's 0, comma, type again for the beginning of the period, so type will be 1. Then close the parentheses, press the enter key, it give you the future value. So this is for annuity due. I believe I've explained this a few minutes ago, but let me compare this with ordinary annuity. The same calculations, but this time we put 0. Okay, annuity. So let's put this something here so I can see the difference. Okay. Now, I want you to watch this. Watch the answer here. Watch this one here. I change this to 0. You can see that it went down to $13,543.81. Okay. So that's it for annuity due and other annuity. I can see the difference in the calculations. Okay. And I have this answer here as well for you. So now, let's look at annuity payment period and interest. Because sometimes we might want to know what is the interest rate or what is our return on investments. How do we get those? Now, 5 variables are involved in the calculation of present value, future value. We have number of period, interest, payment, future value, and present value. Now, if you want to know how many payments will be, what the payments will be, it can be every month or every year. You use what they call a payment function. Okay, and this is how it goes here. Payment and this. when it is if you're looking for the return on investment, use the rate function. We're going to do an example of each of them now. Okay, look at this. Verse 7 says, you just inherited $100,000. Okay, let me make sure you see this. You just inherited $100,000. And 1 minute. Yep. And invested it at 7% per year. How large a withdrawal would you make at the end of each of the next 10 years and end up with zero? That means what you withdraw is payment to you, right? But when you invested it, it's money leaving your pocket, so you gotta be negative 100,000. Then what is coming to you will be your payment. So let's see. Write this down. Interest is 7%. Okay, number of periods is 10 years. Okay. Present value will be how much you invested, $100,000. So it present money leaving your pocket, so you're gonna be negative $100,000. Then future value doesn't have, zero. Time is zero because you usually make the withdrawal. I say here that withdrawal is made at the end of the period, so type will be zero. So let's go and put this in and get our payments. So how to get the payments? 7. So again, we have I think I have right here. Interest is 7%, 0.07. 10 years for number of periods. Present value is how much amount invested. That's 100,000 money that left your pocket. No future value. Type is 0. So how much will you receive every month? So that we, because the question was, you look at the question here, it says, how large a withdrawal could you make at the end of each of the next 10 years to end up with 0? So how much will you pay yourself for the next 10 years? Or how much will you be paying yourself for the next 10 years? Given the interest you have. And the interest rates. You have payments. You can see the formula here, PMT. INPV, future value, and type. PMT. Okay. Opening parenthesis, you can see rate here, 7%, comma. Number of period is 10 years, comma. Present value is PV, amount you invested, comma. No future value, which is 0, comma. Type is also 0. Since you make the payment at or withdraw at the end of the year, press the enter key. I'll give this is how much you'll be withdrawing, which is a good investment, because if it's 100,000, let's say that you didn't invest this, you'll be getting $10,000 a year for 10 years, and then that will finish the money. But here, because of the interest rates, you'll be withdrawing $14,237.05, which is a good deal, a pretty good deal. And you can see the answer here as well. We have it in the presentation here. Like I say, I hope you're getting good at this. Okay, let's look at number 8. This is a kind of investment. Assume that you inherited an annuity that will pay you $10,000 a year for 10 years. With the first payment being made today, that means it is annuity due. A professional investor offers to buy it from you, so give you $60,000 for the annuity. That's so. A professional investor wants to buy the annuity from you for $60,000. If you sell it to him, what is the rate of return he will earn? And if you think a fair rate of return is 6%, how much would you offer him, ask for the annuity? Let's look at the first example. First question. What rate of return will he earn? Let's say that he offered you $60,000 to buy the annuity from you. How much money did he earn? What is his rate of return? Or what is her rate of return? That's what this question means. Before we can answer that, let us write our numbers down. Since we are going to calculate the rate of return, you'll be using the rate function in Excel. Rate function. Let us put them in. The interest rate is, we don't know. That's what they're looking for anyway. So number of periods is 10 years, right? Payment. Money coming to you is, so you're going to be positive, 10,000. Present value, okay? How much he's offering to pay you, buy you for the annuity is $60,000. Okay? There's no future value, so put 0 there. Then for type, put 1, because he says he offered to give you $60,000 for annuity. And for this annuity, the question says that with the first payment being made today, so it is an annuity due. So type will be 1. So the question A says, what is the rate of return he earns in this investment? Okay. To him, who is paying you? Remember, he's paying you, and then so you're receiving 60,000 from him. So it will be positive. Now, he will be receiving the money that from the, when he buys it from you, he will be receiving the $10,000 from the insurance company that owns the annuity. So to an insurance company means negative. The cash flow is negative because 10,000 is leaving from them to him, or even to you when it is you are the owner of the annuity. Okay. So for the insurance companies, it's going to be 10,000, negative 10,000. So let's go and put this in Excel and get our rate for this investment. Okay. Now, number of years is 10 years. Make sure you're seeing this. Yeah. And then payment is okay, negative 10,000, since you're going to be, since the insurance companies, money is leaving their pockets. Present value is how much is offered, will pay you. Money coming in, so it's 60,000. So positive. There's no future value. It's time for this annuity. Payment is made at the beginning of the period, so it is an ordinary, annuity due, so you put 1. So the rate of money in return he's making, how much he's making, is the rate of return will be equals rate. See the formula here, rate function. See, rate. Type in rates, opening parenthesis. Number of periods is 10 years, comma. Payment is 10,000, comma. Present value is 60,000, comma. Future value is 0, because there's no future value. End of the period, that type, this is for end of beginning of the period, so you're gonna be 1, not 0. So 1. Close the parenthesis, press the enter key. So he's receiving, if you make it, I like to make it 2 decimal places. So I'm gonna increase decimal. So 13.7% he's making from you, because he will be collecting, because this is $10,000 payment every month. I'm sorry, every year. So he'll be receiving 100,000, but he bought it from you for 60,000. Remember, this is compound interest. So this is the rate make it for you. So this answers part A of the question. Now, part B says, if you decide that, if you think that the fair rate of return for it should be 6%, how much will you ask for the annuity? Okay. That means we are asked to determine the present value. That is how much you ask for the annuity. That means you're asked to determine the present value if you think the rate should be 6% to be fair. So the interest is 6%. Number of period is 10 years. Payment is $10,000. Future value will be 0, and type is 1 for this annuity. So again, excuse me. $10,000. Remember that this payment, the insurance company is paying. So money, the cash flow direction is negative since the money is leaving their pockets. So we take you to Excel to put this in. So part B, part of the question, interest is 6%, 0.06. Rate of return, number of periods is 10 years. Payment is negative 1,000, 10,000, I mean to say. Future value is 0. Time is 1. So how much should we ask him? So you use it, that means what is the present value? Equals PV, opening parenthesis. So rate, you can see the rate here is 6%, comma. Number of periods is 10 years, comma. Payment is $10,000, comma. There's no future value, so you put 0 there. And then time. But remember, this is payment is made at the beginning of the period. So because the payment is made at the beginning of the period, you're going to use 1. So see 1 here and close it. So you should instead of when he offered you $60,000 and he'll be making 13.7%, and you believe that it is not fair on you that he should make 6%. In that case, how much when he offered you 60,000, you should request for $78,016, $16.92. So that's how much you ask him to pay for the annuity, so that you feel that should be the fair price. I also have it here for you. Okay. Yeah. I'm sure you're enjoying this. So I'm going to show you more on how to find the rates function. How to find the rates function. I've already did with this example, the first one, how to find its rate function. But this is one more example on that. I think I believe that many examples will make you stronger in this. It says here, remember the rate function formula is this. Rate, excuse me, the formula you use in Excel right here. So now, your uncle named you as the beneficiary of his life insurance policy. The insurance company gives you a choice of receiving $100,000 today or $12,000 per year annuity at the end of each year for 12 years. What is the rate of return in the insurance company offering? Again, we have the number of periods is 12 years. Okay. Payment is $12,000 a year. So for them, it's money leaving their pocket. It's going to be negative $12,000 since money is leaving their pocket. Next is present value. How much they offered you now is $100,000 lump sum. Future value, there's no future value. It's there. Type, $12,000 per year at the end of each year. So its type is 0. So we go and put this in, and then so that we can find the rate of return they are offered you. Okay. So let us use this since we have calculated this before. Okay. So I'm gonna paste it here so we can use the rates. Okay. So I can just write rate of return. Insurance companies rate of return they're offering you. I'll call it offered rate of return. Yeah. Okay. So since I've already done this calculation before, just if you watch, once I put numbers, I want you to be watching this. We change it down, give us the answer. It's 12 years. So 12 here. And then payments, money leaving their pocket is negative $12,000. Okay. And the present value is 100,000 for that investment, because it is an insurance premium. Insurance premium, so it's 12, so they offered you 100,000 today, which is present value. It doesn't have a future value. And it's for an end of the period, so change this to 0. So it's 6.1% they offered you. Say 6.1%. And that is what you have here, 6.1%. Or 6.11%, which is basically the same thing they have here. Okay. So I believe I've covered enough grants. Now you can know what annuity is, how to calculate their future value and present value, how to calculate their rate of return, and so on and so forth. I hope you enjoy my lecture tonight. In the next one, we'll be looking at amortized loans. So if you enjoyed it, don't forget to subscribe to my channel so that you will have notification when the new lecture is available. Thank you for listening, and I see you in my next lecture. Bye-bye.